In this video, you will learn how to write the equation of an ellipse given certain critical information. So let's look at example 5. We are given a center at 0, 0, a vertex at 0, negative 10, and a co-vertex at 6, 0. I would start by plotting the different points. So again, we have a center of 0, 0. We have a vertex of 0, negative 10. And we have a co-vertex of 6, 0. If you remember, the length from the center to a vertice is given by the value a. Here, that's a distance of 10. Notice not negative 10 because lengths cannot be negative. Also, the distance from the center to a co-vertice was given by b. Here, that's a length of 6. The length of a, b, and the center are really all that you need to write the equation of an ellipse. So again, I start by kind of writing the basic structure of an ellipse. I know that it has to be two quantities added together equal to 1. Because our vertex is 0, 0, I'm not going to have to worry about adding or subtracting anything to x and y. What I now have to worry about is where to place a squared and b squared. Well, first of all, if a is 10, then a squared is going to be 100. And I can see that that was given to me going vertically. Since that's vertical, that value needs to go underneath the y term. B was a length of 6, so b squared would be 36. And that has to go under x since that was given horizontally. This is the equation of your ellipse. Let's look at number 6. Given a center of 0, 0, a vertex at 4, 0, and a focus at 7, 0, again, I'm going to start by plotting the different values. So here's my center, here's my vertex, and the focus, square root of 7 is about a 2.6. So that would be somewhere roughly here. Now I can start to figure out the different values I need. So again, a is the length from the center to the vertex. So here it's a value of 4. So since a is a value of 4, that means the a squared that I actually need for my equation would be a 16. The other length I'm given is the length from the center to the focus, which is represented by c. Again, here that's a square root of 7. Now I don't need that to write my equation. What I need is b, but I can use that to find the value of b. If you remember, the way that we found the value of c was to take the square root of a squared and subtract b squared. Well, since I know 2 of the 3 variables, I can just plug in what I know and solve for my unknown, which in this case is going to be b squared. Now, first thing, to get rid of my radicals, I'm going to square each side. This will give me just 7 equal to the 16 minus b squared. If I subtract the 16, now I have a negative 9 equals negative b squared, and dividing by negative 1, I get 9 to be b squared. And so for my equation, again, I want x squared and y squared in the numerators because I do not have a vertex different from 0, 0. A squared, again, we found out at the beginning, was a length of 16, and since that was going horizontally, I want that to be underneath the x term. B squared, which we solved for, therefore must be going vertically, and needs to be underneath the y term. Please now pause the video and try number 7 on your own. Please check your answer for example 7. Please notice that when you are squaring the length of c, you need to square not only the root 5, but also the 3 to get a 9 times 5, which gives us our 45. Also notice that because the minor axis, our length of b, was going vertical, that value b squared ended up under y. Therefore, this must have been a horizontal ellipse, and y our a squared 81 ended up underneath the x squared term. At this point, you should be able to write the equation of ellipse given certain critical information.